Okay, so let's have a little bit of a discussion about vectors in physics. All right, so we've already talked about the fact that vectors are a physical quantity that has both a magnitude and a direction. It's represented by an arrow, as you see, and the length of the arrow tells you the magnitude. So if the arrow is longer, it's greater magnitude, shorter, less magnitude. It has a head and a tail, and you always, if you are adding vectors, you always add them from head to tail. So if I had a second vector here, then I would make sure that I drew it off the head of that one. So head to tail of the next. Okay? All right, so graphically, vectors are added head to toe. So if you had these two right here, and you wanted to add them up, okay, here's your first one, B, all right, and then you would put your second one on like this. So you want them head to tail. All right, if you want to mathematically add your vectors, you got to look at the components of each vector. And what I mean by that, you've got to look at your y direction and the x. So this right here is made up of y and x values. So we need to find those. And also understand that the both of these also have positive and negative signs. So basically, if you want to find the resultant, which is the result or the final product, the displacement of that motion, you want to first break your components into x and y. So if we're talking about, like, say, north, east, south, west, okay, going west is going to be negative x, whereas going east is going to be like positive x, and north is going to be like positive y, and south is going to be like negative y. All right, so let's look at an example. Okay, in this one we have somebody traveling 40 kilometers due east and then 73 due south. Okay, so, and it wants to know the displacement. So we have 40 east, and then it goes 73 south. So that arrow should be way bigger. I kind of didn't make the other one small enough. Let's see. There we go. Oh, a little too much, but you guys get the idea. Okay, so let's break them into x's and y's. All right, so our x is going east, and east is positive, so we got positive 40 on this side. All right, and then we only have this in the y. It's south. South is negative, so we got negative 73. All right, and then for your resultant, you just find the product or add those two numbers. Okay, so that gives us negative 33. So the total displacement was negative 33 meters. All right, what if you know the x and the y value and you want to find the hypotenuse? We got to use the Pythagorean theorem. So a squared plus b squared equals c squared. So use a little bit of math and that'll help you find the hypotenuse. So say these are our vectors right here, then this is our hypotenuse. It's going to tell us the displacement. All right, so in order to break a vector up into components, so if you're given the hypotenuse, how do you find your x and y values? Basically, what you want to do is you want to use Sohcahtoa. So I was always told this little mnemonic right here. So if you like that one, you can use it. If you have a different one, you can use that. Okay, so basically, you're just trying to figure out what you don't have. Okay, and then based on that, you're going to pick one of our trig functions to find your unknown. All right, so here's an example. So Sophia kicks a soccer ball with an initial velocity of 8 meters per second at 10 degrees above the horizontal. What are our x and y components? Okay, so we're going, so initial velocity is 8, and then our angle with the horizontal is about 10. So if I went ahead and completed it and made it a right triangle, okay, I want to figure out my y and my x. Okay, so looking at my y, looks like I have the opposite and the hypotenuse. I'm looking for the opposite. I have the hypotenuse and the angle. So I'm going to use sine function here. So sine of my 10 degrees equals opposite over hypotenuse. Okay, so our opposite was y. Our hypotenuse is 8. Now we're just going to do a little bit of algebra. So I'm going to solve this and cross this up. And when I do that, I got my y component is 1.39. And this is velocity, so meters per second. Okay. And then if I am looking for my x component here, my x component is going to be, so we have the angle and the hypotenuse. So this one we're going to use cosine because we're looking for the adjacent. So cosine of the 10 degrees equals adjacent over hypotenuse. So adjacent, hypotenuse, so same thing, cosine of 10, and then cross it up, which gives us an x component of 7.88, and that's meters per second. So there's my x component, and there's my y component.